Lesson 3. First, classification of K3 objects and coordinate systems. Second, 3D solid modeling. Third, surface modeling. And fourth, practice. There are two very important peculiarities of K3 system, namely K3 object classification and the set of coordinate systems. K3 objects. There are several types of objects: linear, line, arc, circle, spline, and so on. Structural, contour, group, rectangle, polygon, polyline, block, and so on. The structural objects are the most frequently used when modeling. All kinematic functions operate with this type of object. The difference between contour object and group object is the following. Contour object is the compound of simple linear objects only, but group object can contain objects of any type. All structural objects can be created when necessary and can be destroyed when needed. A block structural object is not often used except in very specific CAD applications. Polygonal, solid or body in system terminology, surface and all solid primitives. There are four types of coordinate system in K3, which are global coordinate system. It's defined by the K3 automatically. User coordinate system is defined by the user as needed. Local coordinate system. These systems belong to each object in scene. And visual coordinate system. This system defines the visual frame view. Each coordinate system is used when modeling, and UCS is the most convenient and useful type of coordinate system. The user can define it according to the necessity at any modeling step. Let's consider now how structural object and coordinate system are used in real 3D modeling. We'll create a very simple 3D solid model that is shown at the figure. It is the prismatic object with several cuts. First of all, we should decompose the model to primitives. We can make it in many ways, but let's do it in the simplest one. We'll create by extrusion the prismatic solid with parallelepiped cut and with height 80. To make it, we will create the sketch in the YZ plane. We make the appropriate frame active and create the sketch by create lines line command. Lines line. We should type in command line the coordinates of consequent points. First point 0, 0, 0. The second point 0, 40, 0. The next 0, 40, 60. Press enter. The next 0, 40 minus 11, 60. The next 0, 40 minus 11, 80. And the next 0, 0, 80. Press enter, and now we have to select unclose subcommand in the submenu to unclose contour to make it closed. Okay. To apply extrusion function, we have to pull all the lines together to contour object. To make it, we select structural operations contour and click any lines in the chain of lines. The system selects all the lines automatically. We'll create functions create and check it. Okay. Contour flat closed non-self-select intersection. To execute extrusion correctly, we need a closed non-self-intersection contour. Then we extrude the contour by the function create kinematics extrusion. Create kinematics extrusion. We should click the contour After the system request, select subcommand done, and we should define further the height of the prismatic solid, 60, and press enter. Yes. The next we create the prismatic solid in the form of trapeze. We will use now the UCS features in the following way. Click the function conversions, UCS, and define the coordinate system origin like this. Then we should define all the axes, all the system axes. Yes. Before the next actions, let's change current object color. Now we can create a new chain of lines defining the points in new coordinate system. Create lines line. Let's type in command line the coordinates of new points. 0, 0, 0. First point. The next point 0, 50, 0. The next point 30, 20, 0. The next point 30, 0, 0. And now we should select and close subcommand once again. Okay, done. Let's create the new chain in new contour. Create and check it once again. Contour flat, closed, non-self intersections. Okay. We extrude the contour to new trapeze solid. Create kinematics extrusion. Mark the contour after the command request, after the system request. Done. And now we should define the height. However, if you can see in this information panel, the height as we need have a minus sign, so we have to take it into account. The height is minus 40 minus 11 minus 13 and press enter. Okay. The last operation is to subtract the solid from the first solid. To make it, we should create Boolean operations, subtraction, and define the first solid and the second solid. Then press continue subcommand, and now, as you can see, the model is ready. We just obtained its half-tone view and can complete the work. Maybe the last operations once more. We should return our coordinate system in global position. To make it, we use the command conversions UCS and select the subcommand GCS. Okay, and press escape button. Surface modeling. The surface modeling is a very important part of K3 features. There are many branches of industry where surfaces are widely used. The set of surface modeling tools of K3 consists of several very efficient tools. Mesh function. It allows the creation of a surface by the regular point matrix. The user should define this matrix and apply this function to it. By free sections. The user can create the surface based on the set of curvilinear lines. To demonstrate it, let's create several lines by spline command. Create lines spline. First spline, second spline, third spline, and fourth spline. Now we should place it in 3D space to obtain a spatial structure. Okay. Now let's create the surface by 3 sections. Now we should indicate all the splines in order and press done subcommand. There are 2 specific parameters here, say order to smooth. We may simply ignore them, pressing enter to define 2 by default. Okay, this is our surface. By regular sections. This function allows the creation of a surface using several similar sections. Let's create the number of rectangles. Create primitive rectangles. First rectangle, second, third, and fourth. Now we should simply place it vertically to obtain a spatial structure. Okay, this is our spatial structure, and now let's create the surface. Create surfaces by regular sections. We should indicate all the sections in order. All of check please small yellow arrow at each section. All of them should have the same direction. If no, you may use reorient subcommand. Then we should answer the system request. Close up to body. If yes, the system will create the solid. Otherwise, it will create the skin object. Okay, this is our solid object. Okay. Face. The function is used to create, for instance, the plane based on a planar contour. Let's create a rectangle. As we know, the rectangle has a status of contour, and create the face on its basis. Okay, and now, as you can see, we have a membrane object. Sewing function. Sewing functions. This function allows the creation of several surfaces compound. It's a very specific function and we won't consider it. Kunz. This command is intended to Kunz surface creation. To create it, we need 4 or 3 boundary lines. Let's create very simple boundary lines in the arc form. First arc, second arc, and third arc. Okay, this is our boundary arcs. And now we should create a cone surface indicating all the arcs in order, and press create button. This is a very nice cone surface. Ruled surface. To make the ruled surface, we should create two guidelines and mark it in order after the system request. First and second. The ratio should be equal to 2 or more, but it's recommended to keep it equal to 2. And then we should press create button. Okay. This is the ruled surface.